Welcome back to Cosmos Unlocked. In Part 1, we uncovered the fascinating beginnings of the universe and the Big Bang Theory. Now, let's take things even further. What happened before the Big Bang? What mysteries lie ahead as we explore cosmic inflation, the multiverse, and the very nature of our universe? The speed at which it created new space was faster than the speed of light traveling within it. This is the process through which the universe expanded from a tiny, finite point to something larger than the observable universe. During inflation, the universe became larger than the observable cosmos, with some regions moving so far away that their light has yet to reach us. This process of spatial expansion was truly astonishing. In less than 10 to the power of -30, the universe expanded by a factor of 10 to the power of 25. After inflation ended, the universe continued to expand, albeit much slower than before. However, dark energy later caused this expansion to accelerate. Now, the observable universe has a slight chance to win the race because it continues to expand at the speed of light. But how much of the universe beyond the observable part remains unseen? We don't know. That's the topic for the next section. So, how does inflation theory explain the uniformity of the universe? To answer this question, we need to find out how early photons mixed and achieved thermal equilibrium. Inflation theory suggests that at some point before the rapid spatial expansion, these photons were extremely close to one another, solving the problem. Before inflation, the universe was a very small space, giving photons sufficient time to equalize and achieve the same temperature. Once inflation began, these photons were scattered and sent to distant regions. It's hard to imagine how photons separated by such vast distances could have the same temperature, but that's only true for their current state. Before inflation, they were very close together. The seemingly absurd theory of inflation explains this issue clearly. Remarkably, this process hasn't yet ended. Dark energy continues to create new space, though at a much slower rate than during the initial inflation. Now inflation theory has moved beyond just mathematical reasoning. Some observational results also provide evidence supporting the theory. You might ask, how can we confirm events that happened 14 billion years ago? In fact, inflation theory predicts specific features we can observe today in the subtle ripples of the cosmic microwave background. Some of these predictions can be verified through observation. Of course, this doesn't mean inflation theory is definitely correct, as other theories also predict similar features, but it does make inflation theory more credible. In fact, it is through such methods that we understand the origin of the universe. From these ripples, we can estimate the proportions of matter, and dark energy in the universe. Combining this information with the universe's expansion rate, we can model and estimate its age. Inflation theory has other plausible aspects. As mentioned earlier, space is dynamic and can be bent by large amounts of energy and matter. However, in our universe, the amount of matter and energy is just enough to keep space relatively flat. This might seem like a strange coincidence, but inflation theory makes it less puzzling. Inflation naturally tends to make space appear flatter. For example, the surface of a larger planet appears flatter than that of a smaller one. Inflation theory has long predicted that space should be flat. So, does this mean the exploration of this question is over? Certainly not. While we have developed ambitious models of cosmic inflation and have some experimental evidence supporting it, we still don't know what caused inflation. Why did space suddenly expand so dramatically? We really don't know. At this point, we have to step away from science and enter the fuzzy world of philosophy and metaphysics. Currently, most ideas about these questions cannot be tested. Perhaps in the future, smarter scientists will find ways to test them and uncover astonishing truths. In fact, physicists have some ideas about inflation. The good news is that according to one of these ideas, we don't need to find entirely new forces on a cosmic scale, we only need to discover a new type of substance. The idea is this: perhaps the early universe was filled with an unstable new entity that caused rapid inflation. This hypothesis sounds simple, but it leads to two key questions. 1. How did this new substance cause space to expand? 2. Where has this substance gone now? Theoretically, matter could cause space to expand. When discussing general relativity and gravity, we've mentioned how matter can bend and distort space. But what exactly is the process? Gravity typically pulls massive objects closer together, but mass and energy also have properties that can cause space to expand, pushing objects apart. This could be seen as a small clause within general relativity. This property is described by concepts like the energy-momentum tensor and pressure terms. These two concepts might sound quite technical. 601 to 751. Under conditions of negative pressure, matter can cause space to expand. So what happened to the material that triggered inflation when inflation stopped? The answer is that the material that triggered inflation was unstable and eventually decayed or broke down into normal matter. Perhaps we can say that the early universe was filled with something with negative pressure, causing space-time to undergo an incredible period of rapid expansion. In the end, the material that triggered inflation transformed into more common substances, and the rapid expansion stopped. The result was a vast, hot universe filled with dense, normal matter. This may sound crazy, but it explains where inflation came from. You should know that inflation itself is already a theory that sounds crazy, but it resolves many of our puzzles about the early universe. We don't know what this strange material is, but its characteristics are not particularly absurd to physicists. Over the past few decades, with the discovery of dark energy, people have found that it is entirely possible for the universe to contain forces powerful enough to drive expansion. We already know that dark energy is causing the universe to expand faster and faster. We've talked about this before. But we don't know what caused the rapid inflation or whether it's related to dark energy. We simply don't know. After talking about the Big Bang, which is already mysterious enough, it also leads to an even greater mystery. Why was there a Big Bang? What happened before the Big Bang? We can think of the Big Bang as a special moment when the entire universe existed as an extremely small point, with time t=0 and everything came from that initial moment. Now, let's replace that tiny point with a blurry quantum patch, which might be very small or very large. Replace the Big Bang with a very short period of inflation, followed by regular expansion driven by dark energy, and the question still has meaning, but we need to describe it in a new context. We no longer ask what happened before the Big Bang but instead ask where this inflating quantum patch came from. Must this patch become our universe? Are there other possibilities? Will this patch appear again? Did it ever really appear? We don't know the answers to these questions. However, what's exciting is that these questions may have answers. With the right tools, we could look for evidence and solve them. Next, let's talk about a few possible origins of the universe. These include both very simple ideas and bold, imaginative theories. Explanation 1. There is no answer. Not all questions have satisfying answers, because not all questions are well posed. Stephen Hawking once said that asking what happened before the Big Bang is like asking what's north of the North Pole. It has no meaning. At the North Pole, all directions you can go are south, there is no farther north. The geometry of the Earth dictates this. If space-time itself was created at the moment of the Big Bang, then there was no before, and we couldn't know what happened earlier. The universe now operates according to physical laws, and the Big Bang should be explainable by these laws. but because we are inside space-time, we might not be able to access the critical information about what happened before the Big Bang. Inflation might have destroyed the previous world, leaving no clues for us to discover or study. This is frustrating, but the universe has no obligation to satisfy us. Explanation 2. Everything depends on black holes. The core question of inflation theory is, where did the dense material that caused inflation come from? Looking at the universe, our attention turns to black holes. Inside a black hole, matter is strongly compressed. Some physicists speculate that the strange negative pressure that caused inflation may have formed inside a massive black hole. In fact, we can go a step further. Perhaps our entire universe exists inside a giant black hole that contains all known black holes. Furthermore, those black holes that exist within our universe may themselves contain their own miniature universes. These ideas cannot currently be tested, but they sound intriguing. Explanation 3. A cyclical universe. Another explanation is that there might be a cycle. The Big Bang may not have been a one-time event, the one we know could just be one of many. In the distant future, the expansion of the universe might reverse, leading to a collapse, known as the Big Crunch. This collapse would compress all the stars, planets, and dark matter into a tiny, dense patch, triggering another Big Bang. Collapse, then explosion, followed by collapse and explosion again. This could be an endless cycle. However, this explanation has certain theoretical problems, involving the entropy of the universe during the collapse. But then again, this is just a guess in the absence of evidence. If we are willing to consider some wild ideas, we might find a breakthrough. Of course, turning this idea from a creative hypothesis into a testable scientific theory is extremely challenging. 752 to 862, the Big Bang may have already destroyed all evidence of what existed in the previous cycle, meaning that before the next Big Crunch wipes us out, we may never know the answers. A more radical explanation is that perhaps the universe is not alone. It is possible that this strange material with negative pressure expands rapidly and produces more strange material during the process. Although this material eventually decays into normal matter, it may not decay very quickly. If the rate of production of this material exceeds its decay rate, then inflation will continue indefinitely because the newly created material will always outnumber the decayed material. If this theory is correct, then the process that drives inflation is still ongoing. In other words, we are still in the midst of inflation. So what does it look like in places where decay has occurred? Each region of decay represents the end of the Big Bang in that part of space. In these areas, a universe filled with normal matter begins to expand slowly. Each such region can form a pocket universe, and we live in one of these pocket universes. Inflation, in fact, continues, and multiple universes keep appearing. If inflation persists and the rate of space creation exceeds the speed of light, then different pocket universes will never overlap, as the material between them expands too quickly. What are these other pocket universes like? We don't know. Perhaps each pocket universe is similar to ours, governed by the same physical laws, but with slightly different initial conditions. The structure of pocket universes may also be broadly similar. If inflation continues, then there may be infinitely many pocket universes. The word infinite is a very powerful concept because it means that every possibility will occur, no matter how improbable. In an infinite number of universes, an almost impossible event could happen countless times as long as its probability isn't zero. If this theory is correct, it would mean that other universes could contain versions of Earth. On some versions of Earth, dinosaurs that never experienced an asteroid disaster still roam the planet. On others, Vikings might have colonized North America. And on yet others, another version of you might be listening to a different program at this very moment. The fact that we can study the physical clues of the Big Bang is astonishing in itself. It's a bit like someone understanding the circumstances of their own birth using only their own knowledge, without receiving any information from others. Remember, you don't know anyone who was present at the time, and this event took place 14 billion years ago. Compared to such a timescale, our lives on Earth are but fleeting moments. Yet, in this moment, we examine the universe, search for clues, trace back to the origin of time, and look out to the farthest edges of the observable universe. What lies beyond this moment? What might humanity discover? Perhaps one day, we will understand where inflation came from and, in the process, uncover new materials or new properties of existing ones. Perhaps even more exciting things await us. Perhaps one day, our knowledge will extend beyond the origin of the universe, and we will see what happened before the Big Bang. What will we find on the other side? Will it be other universes floating in strange material, or another world undergoing compression? For now, these remain philosophical questions. But one day in the future, they may hold scientific significance, and our descendants may know the answers. Today's philosophy might be tomorrow's science. That's all for this episode on the Big Bang. Feel free to leave a comment and discuss it with me. See you next time.